I'd like to make a presentation on my major research, business analytics for online review helpfulness. So I have focused on suggesting explanatory and predictive analytics for online review attributes. So largely, I have investigated predicting review helpfulness or product sales using the data accrued from such site as Amazon site or movie website for analyzing movie data. In case of Amazon data, I collected data, online review data regarding product reviewer texture attributes. So based upon this data, I tried to explain or predict online review helpfulness, which is a very important attribute and comprehensively examined in previous literature. So so there are major two streams. First stream is using Amazon data, and the second stream is I have used movie data crawled from box office accrued from movie website and explaining and investigating box office revenue. And also, I also investigated or explained online review helpfulness in case of this movie data also. So I categorized data into movie or reviewer or texture attributes and try to examine the interactions of these data. This picture is I try to explain that in general, business analytics can be used for descriptive or predictive or prescriptive analysis. So these three categories of business analytics can be also applied in my research, and I have utilized these three analytics to explain or predict target online review attributes. So, for example, in case of descriptive analysis is about basically what is happened is try to making an answer about what is the distribution of data and characteristics of data. And predictive analytics is trying to make a prediction of the target or outcome variable. So the example question is what will happen or why it will happen. And prescriptive analysis is about focusing on optimization or decision modeling. So it tries to focus on explaining what should I do or why should I do it. So these three analytics are having slightly different purposes. So I fully have full experience of all these three analytics in my research. In case of using movie sample, I collected from movie website, which is containing online review data from a movie about movie, and so these electronic word of mouth data, so-called EWM data, is used. And one of my paper is to to divide this sample according to the review or reviewer helpfulness, and I try to examine the difference between these two samples review according to these two helpfulness variables. So one is a high review or reviewer helpfulness subsample, and the other is a low review and the reviewer helpfulness subsample. So I try to investigate the difference in the value descriptive attributes of online attributes, and also I try to examine the difference in predictive or predictive accuracy. So I try to explain. The conclusion is the more greater predictive accuracy was found in the high review or reviewer helpfulness sample, because helpfulness is meaning that sample is more high review. Helpfulness sample means kind of quality of the sample, so it results in more greater predictive accuracy. So in my paper, I try to make that conclusion. So I have applied various machine learning methods and compare the predictive accuracy between two samples, high or low review and reviewer helpfulness. Not just analyzing this predictive accuracy. Also, I tried to making a research on explanatory analytics. So this is just one example. So I set out the independent variable and dependent variable. Dependent variable is the box office revenue, and independent variable, much frequently used variable is include volume and valence. Volume is number of reviews. Valence is the rating of movies. And there are also sentimental variables like number of emotional reviews or number of positive reviews. And the other values are review extremity or length of reviews. So these variables are comprising determinants to the box office revenue, and how I want to show how this relationship can be moderated by reviewer helpfulness. So this table shows that the comparison between high or low reviews subsample or high and low review or reviewer helpfulness subsample. So in generally, overall, the results support that in case of high review or reviewer helpfulness, the predictive accuracy is increasing. So this picture shows this table shows the average prediction error. So you can find that average error is smaller in high reviewer and high review or reviewer helpfulness subsample. Okay, so this means that this prediction error is decreasing in the high review or reviewer helpfulness subsample, and that difference is many cases the difference is significant according to the t value, t statistics. Okay, this picture is showing that I also in some other research used the neural network very typical approach for neural network is a propagation neural network model. So I applied this back propagation model to predict review helpfulness. Then independent variables are about 20 variables, and they are representing various product variables related to products or review or reviewer. Okay, so these are there are overall 3 groups of independent variables: product or review or reviewer variables. And it turns out that the predictive accuracy of neural network model is significantly higher than that of statistical method. In this case, multiple regression method. So our backpropagation neural net model outperforms multiple regression model according to our result. Not only that, we also show that one of the drawback of neural network method is kind of black box, but we try to explain how independent variables are contributing to the dependent variable using some measure which is suggested by previous literature. So this RS means relative strength between I's input and J's output variable. So based upon this measure, we are trying to show that we can also indicate which variable is contributing more to the output or outcome variable. So this table is the result of that analysis of that RS measure, relative strength measure. So in this gray shaded row represent the variable that has some greater relative strength on the helpfulness. And this table is in another study. We also apply decision tree analysis method, so suggesting rules, various decision rules, which is to making a conclusion about helpfulness. In this case, helpfulness is calculated as dichotomous variable, high and low, not continuous variable. So in these rules, these rules are designed to suggest whether helpfulness is low or high according to various conditions about other review attributes. Like in case of with respect to the review attributes or reviewer attributes or product attributes, based upon these attributes value, what is the conclusion about the helpfulness class, okay, high or low, or 0 or 1. So these rules also suggested the value for support, confidence, and capture of the rules. Okay, so this is another. This is the extension of previous table. Okay, so I will skip that. And not only suggesting rules, we also compare decision tree method, the accuracy of this predictive accuracy of decision tree method with other machine learning methods such as k-nearest neighbor or discriminant analysis. So it shows that distance tree method is a very outperforming the other methods of machine learning method or statistical method like discriminant analysis. In our study, we also applied Bayesian network, naive Bayesian network. NBN is a naive Bayesian network. So we applied Bayesian network model as a primary machine learning model, and then compared this model, naive Bayesian network model, with other methods such as the multiple discriminant analysis or k-nearest neighbor method, KNN, or MDA, or NN. NN is a neural network model. So we have compared naive Bayesian network model NBN with MDA or KNN and NN, three machine learning methods. And overall, naive Bayesian network is outperforming the other three methods. Okay, not just we have done research on. I have done the research on this predictive analytics regarding online review data, but also I also applied explanatory analytics to explain the interrelationships or causal relationships or moderating relationships between among these online review attributes. So in dependent variable, there is a primary online review happiness, and this online review happiness is subsequently contributing to product sales or box office revenue in case of movie sample. And in the independent variables group, there are largely three groups: product related features, source-based features means reviewer related data, and content-based features mean that review-based data, review structure or review texture characteristics. Okay, so these three groups of data is contributing to online review happiness. Some of these the variables contribute to online review happiness, and this causal relationship is also moderated by some other variable like product type. Product type means whether it is experience goods or search goods. Or also the effect of online review happiness on product sales is also moderated by product-based features like average review rating or average review depth. So these all relationships are suggested as a hypothesis and tested with multiple regression analysis with the interaction terms. Interaction terms means two variables are in the same term because these two variables are interacting with each other. One variable is moderating the effect of the other variables on dependent variable, in this case helpfulness or product sales, which is represented by sales rank. So we are using appending interaction term to test this moderating hypothesis. So this table shows generally our research hypotheses are supported, maybe with some exceptions, but anyway, we have many of our hypotheses are supported in the moderation effect, also in the directing in the direct effect. Okay, so so I have finished my presentation. I have finished my presentation on business analytics for online review helpfulness, and this is roughly my progress until now about this research stream. There are other streams also, but this stream is very, I think, promising, and I think important among the whole of my research streams. So I have selected this subject in my presentation. Thank you for listening to my presentation.